All right. Focus. 3.3 or no 3.4. Day number 2. This part's gonna be really quick. Okay. Not long at all. You're talking about 4 or 5 slides. No big deal. Okay. So we're gonna solve these by factoring again. The first one here, you have a trinomial. X squared plus 16x plus 64 equals 0. You do this one the same way as you did with yesterday. You look for your multiplied number. You look for your add number. All right, multiplied number is 64, and your add number is 16. So you try to figure out what two numbers multiply to 64 and add to 16. 8 and 8. All right, now pay attention to this one. This is very special. Does anybody know what this trinomial is called?
B. A, X.
No.
No, it's not.
It's got a special name since it factors that way.
Perfect number.
Perfect square.
One more.
Trinomial.
Very good. Perfect square trinomial. All right? Because it factors to two same binomials. See that?
Oh, can you just put X plus 8 parentheses squared?
Not yet.
Ooh.
Okay? I want you guys to do this with this. I want you to put a big star next to this guy.
I just circled it.
That's fine. And put 3.5 next to it. Okay. Yes, we are. All right. But for now, all you do the same thing we've been doing. Just split them off and solve them. All right. X plus 8 equals 0. X equals negative 8. And over here, X equals negative 8. Now, the second one you might have an idea of how to do, but I'm going to actually go make it equal 0 because I want to solve this by factoring. So you have x squared minus 64 equals 0. Okay? Now, this one you obviously can tell is not a trinomial as it's written, right? Everybody see that? You can treat it when you factor it like one, though. Okay? So you can look at that and still do it with your trinomial logic. All right? What multiplies to negative 64 and adds, in this case, it would be what?
To 0.
To 0.
Which is 8.
And?
8.
No. 8 and negative 8.
That's why it's plus minus.
Right.
Wait, for that one, would you...
Actually,
I have a question.
what's up, Texas?
On the left one, you have 2 x's. Do they both fit into both? Like they both. Like if you have 2 x's, how do you know which x goes to which one? Like how would you tell? Like if we just wrote x equals negative 8 and x equals like negative 4, if that was like the other number.
You would just roll it with because you're doing these in or cases. Okay, so like this one it doesn't matter because they're the same number. But it would be x equals negative 8 or x equals whatever this one would be. You never have like both of them at the same time. Okay, makes sense. So like for over here, when you solve this one up, you split them off. X plus 8 equals 0.
Because like for that one, or the right one, couldn't you put plus minus?
You could, yes. But like you said, you could put plus or minus, but the key word in there that I always skip over because I talk fast is or. Plus or minus. You're never talking about these at the same time. You're never like trying to plug these numbers in simultaneously and see if it works because it doesn't. Okay? Also?
Why is the answer not just 8?
On the second one?
X equals 8, yeah.
Because whenever you FOIL this x squared minus 64 up here, when you multiply and add up to the numbers to negative 64 and 0, one's positive 8, one's negative 8. So when you split them off into the two solves, you're going to get negative 8 and positive 8. So it's not the same like it was over here.
Could it also equal 8 though? Because 8 squared equals 64.
It's a square. 8, negative 8.
That's what we're talking about. See, you're talking about one or the other at a time. So like 8 squared is 64, so that one works. But in a separate instance, negative 8 squared is also 64. Okay, makes sense? Anybody know what this factoring is called?
Reverse factor.
No. It's a little trickier. I think it's a little harder than perfect
Back
squares.
to front factor.
No. It's not something I made up. It's called difference of squares. Okay. It's called difference of squares. You don't have to know it. It does factor that specific way, where it's the square root of it and plus and minus. But if you treat it just like a trinomial, you'll get it just the same. Okay. All right. Now this one is probably, I think, one of the more complicated ones that you're going to do. One like this. To start with, though, I want to factor this guy first. Okay, I don't want to solve it. So ignore the equals 0. We're just going to do 18x squared plus 15x minus 12. Okay. Now, here's what you need to start training your brain to. I see everybody's hands moving, calculators moving, everybody's trying to do 18 times 12, right? Okay. Here's what I'm going to tell you first. Look at your numbers and look at them carefully. Stone.
Divisible by 3.
They are all divisible by 3.
Triple.
Okay? So here's what I'm saying. So ignore the equals 0 part because that is key here. And you can take a GCF of 3 out. So 3 parentheses 6x squared plus 5x minus 4.
Wow.
Okay.
Equals 0
Nope. No equals 0 in this example.
Oh, at all?
Not at all.
I thought you were just giving it from the beginning.
Not at all. We'll do it. We'll do it with equals 0 in just a sec. Okay. Okay. Stone, you said what that first number was. What was it? When you multiplied 12 and 18?
216
216.
divided by 3.
Okay. So now see how nicer your... No, that's not going to be it.
Dang, you're 72.
Yeah. See how much nicer your numbers are going to work out to be now?
Yeah.
That you took out that perfect square? Or that GCF, rather?
Oh, you just took it out.
Right.
Oh, and so it'd be 4 and 1 because it has to be 5, but it's
Well, you need to do 6 times negative 24 and add a 5. Okay?
so added to 5.
Add to 5, multiplies to negative 24.
Wait, why does that do the negative 24 again?
It'd be 8 and 3.
6 times 4.
8 and 3.
Oh, okay.
Okay? So 3
Yeah.
x minus 3 plus 8. Now, notice how this GCF of 3 tags along here?
Yeah.
Because remember, you need to be able to multiply this back to the top. So if you lose this somewhere along the way, you will never get back up here. So you need to make sure you have that, okay, Stone?
Now do you have to put that 6?
Yes. Now you do your bottoms up step. Do 6 and 6 here. Reduce them if you can. So 3 parentheses x minus 1/2 x plus 4/3 and move them up. So 3, 2x minus 1, and 3x plus 4.
So if you're going to
Okay. Now same exact problem, but now we're going to solve it, okay? So here's the main difference between solving and simplifying. Simplifying, you can't just get rid of things. You have to make sure everything stays accounted for. Solving, you're just trying to get down to x equals this, x equals that, and you really don't care how you do it. Okay? So whenever we look at those same 3 numbers, we still know all 3 of those numbers are divisible by what?
3, so you can just
So
divide
3. So yes, since it's an equation now, you just divide both sides by 3. Because that's a legal equation move, right? So divide everything here by 3. Divide that side by 3. And it gets you down to that 6x squared plus 5x minus 4 equals 0. See, on the solving example, your factor of 3 can disappear. Because you don't really care about it because you just want to figure out what x equals. Over on the factor side, it has to be there because otherwise this expression won't FOIL back to what you originally started with, and that's what you want to have happen. Okay, Martins.
When I was solving equations, what you did, the one side you had to do the
You do,
other.
yes, correct.
So why wouldn't it be negative 3?
0
0
divided
to 3 is
0 divided by 3 is 0.
Oh, sorry.
It's all good. All right. Now, from here, obviously this problem factors the same way this one did, yes? Okay. So we can pick it up from there, right? So x plus minus 1/2 X plus 4/3 equals 0. X equals 1/2. X equals negative 4/3. Last example. Write quadratic equations in standard form with the following roots: negative 1/3 and 6. All right, now, anybody remember what a root is?
Yes.
What is it? Please don't say something that's attached to a tree.
A square. Roots. Versus background. Background.
It's
Huh?
a root.
Yeah, roots. Like someone's background.
Miss Harris, it's where the graph of the quadratic equation crosses the x-axis. Thank you. Now, what we've been doing...
Roots. Oh.
No, stop. What we've been doing is solving these. Getting x equals this, x equals that. Those have been roots. Now they're giving us the roots. And now you work backwards.
Ah.
Okay? So, literally work it backwards. X equals negative 1/3. X equals 6. Stone.
Would it be positive?
Nope. X equals negative 1/3. X equals 6. Okay? Now, you're going to turn those into the binomials from which they came from. Okay? From which they came from. So how did I get x equals 6? Let's start on the right
It's gonna
side.
be a negative 6.
It came from x minus 6, right?
Yeah.
Alright, makes sense? It came from x minus 6 equals 0, and it turned into an x equals 6. So make it an x minus 6.
And the other one is x plus 1/3.
Now, here's my question, though. Do you want to deal with that fraction?
No. No, you
Okay.
got bottoms up.
Kind of, yeah.
Oh, wait, so-
So, now think about this before you start yelling out crap. How did we get that negative 1/3?
Because the
Reverse engineer it. Where did it come from?
top of the first fraction.
Harris. You subtracted a 1,
No, the 3 came
You
from...
divided by a
the
3.
and you
came
divided
from
by a
left.
3.
So you do the bottom.
So you subtracted a 1 over, and you divided by a 3. Throw that in reverse. Multiply by a 3, and add a 1.
So it'd be 4.
No. Multiply both sides by 3.
Oh, that'd be 3x equals 1.
Add a 1.
Okay. Okay.
Alright? Make sense? Just 3x plus 1. Think about it now. 3x plus 1, if it equaled 0, excuse me. If it would equal 0, you subtract that 1 over, divide it by 3. That's how you got that negative 1/3. Okay? You're reverse engineering a problem from where it came from. Make sense? What do you do next? Foil. So 3x times x, 3x squared, 3x times negative 6, negative 18x, plus x, minus 6.
So really, no matter what, there's going to be something.
About not really.